Good afternoon everyone and welcome to this another session on engineering graphics with me Yash Chawla, lecturer of Mechanical Engineering Department at Parul Institute of Engineering and Technology. In the previous session we started with curves and we are going to continue with engineering curves. Now engineering curves we had now what we are going to discuss is we are going to discuss parabola and we are going to discuss hyperbola, the construction various methods that are available. Just refreshing about conics parabola. What is parabola? Parabola is a curve that is obtained as a view when we are cutting a cone with a plane which is parallel to the slant edge of the cone, which is shown on your screen. You can view there on the screen. And for parabola, eccentricity is equal to 1. I hope you remember what is eccentricity. It is the distance of a point from the focus divided by distance of a point from the directrix. Okay, so let's move on. The different methods that we are going to discuss is we are going to discuss 4 different methods of construction of parabola. First is the rectangle method, second is the parallelogram method, third is tangent method, and then we have the directrix and focus method. Okay, so first we will start up with the rectangle method. There is some problem with the slide, just one moment. Yeah. Now for the rectangle method, the base will be given and the height will be given. The base is basically, you can say, the range, you can also mention the range, and the height means the maximum height that can happen. Now the question that we are going to discuss here is throwing a stone from a bank of a river. We say the stone attains a maximum height of 20 meters and it goes to up till a distance of 100 meters. So if I am throwing a stone and it goes up till a maximum height of 20 meters, so that will be my height, and it lands after 100 meters from the point where I threw it, so that is my range or the base, which is 100 meters. Okay, so now what we'll do is we'll take we'll draw it on the sheet. We'll draw a rectangle which is of we will take it as 15 and 30, 15 centimeters wide and 30 centimeters broad. Please begin with that. Width will be equal to the distance covered and height will be equal to the maximum height attained by the projectile. Okay, be quick. ये 30 लेना है,
इससे ज़्यादा हो जाएगा 30
कितना है 15
14 किया ना
15 yeah okay 3 ले लें okay now you can bus now. Okay, now draw this, make it a rectangle of this size. Nice, Aman. This is good. I'm sorry. Okay, now mark it as PQRS. Now next we will mark the point of maximum height, that is C. We will consider it as the center. Point of the maximum height attained is C. Then we will divide PS, QR, SD and DR into 7 parts. Divide this PS into 7 different parts. Seven different parts, then QR into 7 different parts, SD into 7 different parts and DR into 7 different parts. 7, 7, 7. Now for the viewers, I'm depicting it on the screen. This is how you will be dividing it. 1 2 3 4 5 6 7. First ST got divided, now DR is being divided. नीचे वाला करना है DR. ये this you have to divide this. This has to be divided. For ellipse we divide this. For this we divide this. Yeah. Okay. For all of you at home, you can draw it with us because it will take. It's being drawn in real time, which is being shown in the cam. Divide this. First, mark it PQRS. PQRS. CD. Yeah. Now mark this points as 1. This is 1, 2, 3, 4, 5, 6, 7. Same 1, 2, 3, 4, 5, 6, 7. Divide this into 7 parts. Yeah. 7 parts. Mark it as 1, 2, 3, 4, 5, 6, 7. Okay. This is 1, not this. This is 1. 1, 2, 3, 4, 5, 6, 7. Do it for the other side as well. 7, good. 7, yes, right. Okay. Okay, once we are done with that, are we done with that? Okay. Now the next, with draw a line connecting C and 1. And then C and 2, C and 3, C and 4, C and 5, C and 6, and then like this, which is being shown on the screen, C21, C22, C23, C24, C25, C26, C27, and similarly on the other side, just connect them all. That is good, Vipin. Yeah, just always keep a cloth with you, and don't this should be rubbed off with a piece of cloth. Okay. So once you are done by done connecting these lines from C, now from 1 draw a line exactly parallel to CD which connects C1 at 1 dash. P1, and similarly you will connect all the lines upwards from 2, 3, 4, 5, 6, 7, and then on the other side. Continuously, at when you mark this point, you have to mark it as P1, this as P2. And now we have all the points P1 to P7 and P1 dash to P2 dash, P1 dash to P7 dash. P1 dash, P2 dash, good. That's good, Aman. Aman is making a scaled drawing of this, which has it has a zoomed effect, a scaled drawing. Yes, we can show this sheet as Aman, if you once you complete, then let the cameras be on it. Okay, and then finally when we connect all the dots via smooth curve, we have an ellipse. Good, Vipin. A hyperbola, parabola. The required parabola comes when we have joined the line. Good. So we can just zoom in onto this. This is the required parabola. Now here, whenever you are drawing this, you have to show the measurements of it. So when measurement, what is this measurement? You have to mark it from here. Yes. No engineering drawing is finished without a measurement, writing the measurement. Horizontal lines from here. Yes. And similarly, the same will go for the vertical lines. So this is what a complete parabola looks like. Mention the unit as centimeters. So that is a complete solution. So now we will move on to the next parallelogram method. Now for you guys, just keep an eye, because this is very similar to what the oblong method is. The only difference that is going to come here is that for instead of a square, instead of a rectangle, here we are going to have a parallelogram. Parallelogram is what? Its base will be making an angle with the horizontal. It won't be a simple straight line, a parallel line to the horizontal. It will be making an angle, just like it is depicted in the figure. If we take all the things as it is given in the previous question and we take the angle as theta, so the same procedure we have to repeat. We have to mark C and D, and then C and D will be joined, and once we have joined C and D, we will divide everything into 6 parts or 8 different parts or 10 different parts, depending on how accurate we want. The more the number of parts that we use, the more accurate will be the parabola. And then again dividing PS first into 6 parts as mentioned in the previous slide. Then after that the next is dividing all into QR into equal parts, that is 6 equal parts, then SD and DR into 6 different parts as seen on your screen. Now similar to the oblong method, what we will do is we will be joining C1 to C2, C3, C4, C5, C6. I'll show you one by one. Yeah, C1, C2, C3, C4, and then again C1 dash, C2 dash, C3 dash, C4 dash, C5 dash, and C6 dash, that is C2R. And then again, now here from 1 we drew exactly perpendicular line to the base. Now here what will happen is that we will be having line which is parallel to CD. From 1 we will be having a line parallel to CD which will go and intersect C1 at P1, and similarly from 1 dash we will have at P1 dash, from P2, P3, P4, P5, and similarly on the dash side we will have these all points. And once we obtain all these points, then what we will have is, we will have a parabola like this. So this is the required parabola. If this method is given, then how you are going to identify it. Say for example, I told you in the previous question, I told you that we are throwing a stone from the base. It is attaining a maximum height of 20 meters and then falling after 100 meters. Now another point will be, the projectile is being launched from the ground level. It attains a maximum height of 20 meters, and at 100 meters I am catching it 5 meters above the ground. So what will happen is, in the previous question A and B both were at ground level. Now A is at ground level but B is at 5 meters. So that angle will be the angle which, so this method will be used. Understood? Yes. Done. Okay. Now let's go for the tangent method. Now this is another interesting method that we use. For this we need the base width and the height. Okay. So we'll move on. First step, we'll take the same question that we had taken, that we are throwing a stone which is attaining a maximum height of 20 meters and the base is 100 meters. So according to the scale, we have to draw a triangle PQR with base as the width given, and height of the axis is twice the height. So you can keep it here, or you can make it here. Yeah. Aman, you can make the scaled up here. Okay. Height will be twice the base height. So if you are taking 10 centimeters, then the height will be 20 centimeters. Begin. So for the viewers, it is on the screen, is depicted PQR is a rectangle, and from the center axis has to be drawn as PO, which is shown by the dotted line that is dash, long and short dashes, which depicts the center. Height will be double. Okay, okay. Okay. We'll be taking this one. Okay. Long and short, combine these two. Long, short, long, short.
Okay.
No problem, like this. Long, short. Okay, long, short, that depicts the center. Okay, now moving on, what we will do is we will divide PQ and PR into 10 equal parts. That is, both the slant edges we will divide into 10 equal parts. Now one thing is to be remembered here. Now say slant edges we are both dividing into 10 parts. If you are numbering it 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7 and 9, 10. Then on the other edge it will be reversed, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So it has to be 1, 2, 3, 4, 5, 6, 7 and 9, 10, 1, 2, 3, 4, 5, 6, 7 and 9, 10, or 1, 2, 3, 4, 5, 6, 7 and 9, 10, 1, 2, 3, 4, 5, 6, 7 and 9, 10. One in ascending order from top to bottom and one in descending order from top to bottom. Always use this to cut into equal parts. This will give you an accurate thing. Say this is this. So this makes your work quicker.